Hello everyone, welcome back to the channel. Welcome back to another video in the series of data structures and algorithm. Right, this is the continuation of the existing series that where we already understood what a data structure is. We have taken a non-example of from my room itself. Right, so in this video we'll be understanding about what is an algorithm. Right, so if I start with the definition, let's get into the content already. Right, so if I start with the definition, right, so an algorithm is a step-by-step process of solving a particular problem, right? You have a problem in hand, right? You have a solution in hand. That solution is performed in multiple steps, right? So that solution of multiple steps is what we call one algorithm to solve this particular problem, right? Now you can solve this particular problem using multiple ways, right? One way might have 3 steps, one way might have 4 steps, one way might have 100 steps, right? But all of those can be considered as some sort of algorithm. There could be bad algorithm or good algorithm, right? It's remember, we are not calling bad algorithm which are not actually solving any problem. All those algorithms are solving this particular problem, but some are solving in a faster way, some are solving in the slow way, right? But all of those are considered as an algorithm. So let me reiterate this definition. An algorithm is the step-by-step process of solving a problem. Now I'm going to take 2 examples here, right? One example of me going to office from here. Let's say my office is somewhere in 20 kilometers away, right? So from here there could be one possible solution that step 1, pack your laptop. Step 2, get to the main route. Step 3, follow the metro route. Step 4, reach the Wipro circle. Step 5, go to the office building, right? That is 5 steps. These 5 steps are one algorithm, right? But what if I have some alternate routes, right? What if I decide to go to a park before going to office? What if I decide to have a coffee in between to go to the office? Now step 1, right, pack my laptop. Step 2, get to the main road. Step 3, get to the park, right? Step 4, have a walk. Step 5, back to the metro route. Step 6, right, follow the metro route. Step 7, go to the cafe, right? Step 8, finish your coffee. Step 9, get back to the metro route. Step 10, get to the Wipro circle or get to the nearby office, right? Step 11 would be reaching the office. Now you see one solution has 5 steps to reach to office and another one has 11 steps to reach to office, right? Source and destination was the same. Source was my room and destination is my office. That is not changing. And in both scenarios we are solving the problem that is going to office from source to destination, right? So 5 steps is an optimized algorithm, is a better algorithm to reach to office, right? Although I would still prefer having coffee and going to a park, right? But and in general we are reducing the steps, right? So that is the algorithm. Basically we are solving the problem of going to office in both of those algorithms, and there are steps in each of those algorithms, right? One has 5 steps, one has 11 steps. That is what considered as an algorithm. Now let's take another example. Maybe the office example is not that much understandable, or you might need one more example to understand it well. Let's take an example of Maggie. For example, me as a bachelor, right? When I used to live in hostel, right? In night time, they used to close everything at 12 o'clock or 1 a.m., right? We used to get hungry at 2:30 at night, right? At that time, you can't even get idli dosa out here, right? At some places you can still get it, but mostly you cannot get it. So obviously, the only one thing that comes to rescue is Maggie, right? So let's say you have to prepare Maggie, right? So to prepare Maggie, what you can do, you can put some water you can boil some water, right, in the bowl. You can add Maggie to it. You can add Maggie masala to it. You can let it boil for to 3 minutes, and that's it, it's ready. So what are the steps that you follow to prepare Maggi? Obviously, take the Maggi, tear the packet, take the Maggi out, boil the water for 1 minute, 2 minutes, add Maggi in that, right? These are the steps. Okay, I'm not calling step 1, step 2. These are the steps that I'm mentioning. You add Maggi to the water bowl, right? You add Maggi masala there, you let it, you leave it for boiling for 2-3 minutes, and then you get back to it. That is one way of preparing Maggi, right? Let's say it took 5 steps, right? Now, your internal cook might be alive at night, right? You have a lot of free time, right? You're not getting sleep anyways, so you decide to make a Maggi very interesting process, right? You boil the water, obviously use the Maggi masala and Maggi, obviously, because without those it won't be Maggi, it will be something else, right? You decide to add veggies to it. You added sweet corn there, right? You added some mushroom in that. I have never eaten mushroom in Maggi. Okay, let's say you added sweet corn there, right? And you added some cheese there, right? And you prepared it in such a in a different way that required, let's say, 5 more steps, right? So what was the objective? What was the problem that you are trying to solve here? The problem was to prepare Maggi, right? But in first algorithm, the steps that you followed were very simple steps, where after following 5 steps, your Maggi was prepared, it was done, right? But in a different way, where your internal cook was alive, right? And you started adding cheese to it, sweet corn to it, right? It took 5 more steps. Now you are achieving the same objective, which is preparing the Maggi, right? So the problem is still the same, but the way of solving it is different now, right? Because you added some extra steps to it. Now that is also an algorithm, right? And although you're adding more steps, it's taking more time. Your Maggi is in the end it's becoming tasty, right? So that is the trade-off that you see there, right? You're adding more steps, which is taking more time, but your Maggi is becoming more tastier, right? That is we'll be talking about the trade-offs of all these trades off in the actual algorithms, although, right? Where to save particular time, the particular algorithm takes more space in the recursion. It happens mostly, right? So even there are optimized for that also in DP and all, right? But you understand the intent. So what is an algorithm again? So an algorithm is a step-by-step way of solving a problem, right? A first example we have taken where we are trying to solve the problem of me, reaching to the office. Source was the same, my room. Destination was the office. In one it took 5 steps, in one it took 11 steps, right? So both are considered as an algorithm, right? And the second example we have taken is of preparing a Maggi, right? Where in a first method, the Maggi was prepared in 5 steps. In the second way, where you added cheese and corn and all that, it's prepared in almost 10 steps, right? And then I told you about the trade-off also, right? Those extra steps, although they have taken more time, but they make the Maggi more tastier, right? So the way of solving a particular problem, right? In simple words, that is what we call an algorithm, right? Those steps, that is a step-by-step process that we are calling as an algorithm. In the actual, we have talked enough about these non-tech problems, right? Let's talk about some real technical stuff, right? Let's talk about searching something, right? You have a big list, right? You want to search for something. Now there are 100 items in the list, right? You're looking for a particular number which is there at the end of the list, right? So you'll have to go through from the start to end to find that particular number, right? Now there are better algorithms of searching, like binary search is there. You're looking for a particular number, right? You divide your list in such a way that you're able to solve it in a very less amount of time. You're literally you literally, dividing your list into two parts and just leaving one part of it right there. Because the element you are searching for doesn't exist there, right? Similarly, you are sorting algorithms, right? We have a bad algorithms, right? Bubble sort and all that. We have good algorithms, right? Merge sort and quick sort, right? So I hope you understood in a gist what is an algorithm. Let me reiterate it again. So an algorithm is a step-by-step process of solving a problem, right? Now these steps could be less, these steps could be more, right? And there could be trade-offs involved with that, right? With those steps. We will talk about those trade-offs, we'll talk about those steps involved, we'll talk about different types of algorithms, right? Searching algorithms, sorting algorithms, there are greedy algorithms, right? And there are many actually, right? So you have Prim's algorithm, Dijkstra algorithm, DFS, BFS, Prim's. We will be talking about all those algorithms basically with the use case and the implementation. So yeah, I hope you understood what an algorithm is. In next video, we'll be talking about what is time complexity, what is space complexity, what is big O notation, right? What are different big O notations available to represent that time and space complexity. Once you understand, in the next video itself, like fourth video, we'll be getting into the real, we'll be getting into the game of actual data structures, which is arrays. So yeah, I hope you understand what an algorithm is, right? Please feel free to share your thoughts and comments, or share the video if you are able to understand, and I'll see you in the next video. Till then, may the source be with you. Bye bye.